And question 3, it says David and Anita make mailboxes and toys in their craft shop near Hialeah. Mailboxes are sold for 15 each, and they require 1 hour of work from David and then 2 hours of work from Anita. Toys are sold at $22 each, and they require 1 hour of work from David and 1 hour of work from Anita. David cannot work more than 7 hours per week, and Anita cannot work more than 12 hours per week. They're asking us to do how many mailboxes and toys should they produce in order to maximize their revenue, right? And then what is the maximum revenue? So for this, we're going to go ahead and do a little template, and we're going to put input. So I'm going to do it one by one, not like he did it on the video. So let's start with input. So what is it that they're giving us? They're giving us a price, right? And then the two products are going to be what? Mailboxes and toys, right? And toys. Let me put this a little bit bigger for me. Okay. Mailboxes and toys. So we have the price, right, of the mailboxes. Then what else do they give us? They give us David's time, right? David's time. And then Anita's time. And then, so let's look at the price. They said that they sell the mailboxes at $15 each. And that they sell the toys at $22 each. So these are going to be dollars. So I'm going to select these two, go to the Home tab, and then in here, I'm going to go ahead and put currency, right? Let me take this here so it looks cleaner. So David's time, how much time does it take David to make one mailbox? So here in the problem it says that mailboxes are sold at 15. They require 1 hour from David. So 1 hour from David, and then how long does it take David to do one toy? Toys are sold at 22, and they require 1 hour from David. So 1 hour from David. What about Anita? So in mailboxes, it says Anita takes 2 hours to do mailboxes. And what about the toys? So toys, and then it takes 1 hour from Anita, right, to get a toy done. So that's going to be our little table for the first part. And so we're going to continue with the second part. So let me put this in just so it's different. Okay. So just so we copy the same standard, I'm going to Control C, Control V, or Command. Now we're going to do the decision variable. So what is it going to be, your decision variable? Well, the decision variable is going to be how many, right? How many mailboxes is how many toys to produce. So we're going to put here how many to produce. And then we're going to copy this same thing, right? Control C and then Control V. So how many mailboxes and how many toys do we need to produce? Because this is the one that we're going to use the solver for, and so we can differentiate, I'm going to put this in yellow, right? So after the decision variable, what comes? So again, I'm going to put Control V so it's consistent. So after the decision variable, we're going to put here our model/objective. Okay, what is going to be our model/objective? We're going to do the same thing. We're going to copy here just so it is consistent, and when we're looking at results, we know what we're looking at. So what is the model or the objective? Well, it says here that what is their maximum revenue. So they want to maximize, right, the revenue. So we're going to put here maximize revenue. So what is revenue? So revenue is going to be, we're going to equal to how many to produce, right? That should be kind of like the demand that we were talking about in the last exercise, times what? The price, right? And we're talking about mailboxes, mailboxes. You see that's what we're putting in here? So it's easier for us to go ahead and reference it. So we're going to hit enter. And if I scroll it to the side, it's going to do the same thing, right? It's going to go back to the demand of the toys times the price for each toy, right? Okay, so now we're going to go ahead and do total profit, right? So we're going to do total. Why? Because the profit is going to be the sum of who? Of these two items that they're selling, right? And then I'm going to hit enter. So nothing now has, any total or anything like that until we run the solver. After model and objective. After model and objective, we're going to go ahead and we're going to have the constraints. So now, what are the constraints? For me, since to be easier, hold on, constraints. For me, so it's easier to remember, constraints are kind of like the limits or the stoppers that they're putting you. So for example, so we don't complicate ourselves so much. It says David cannot work more than 7 hours. So that's a constraint. David can work 6 hours, but cannot work 7 hours and a half. So he has up to 7 hours to work. Same thing with Anita. She cannot work more than 12 hours per week. She can work 12. She cannot work 12.5. She can work 5 hours. So those are kind of limits that they're putting us in this problem in order for us to know how many mailboxes or how many toys do we need to produce. We can't produce. Okay, so for constraints. So we're going to put here David's time. So we're going to copy these two, right? These are going to be our constraints because it's for these two, right? People specifically. So what would be the first one? So we're going to put here value, right? And then we're going to put the operator. What the operator is going to do, it's going to tell us if it's less than, more than, equal to, stuff like that. So it's easier when we do the solver. And then for the third one, we're going to put the constraint. Constraint. Okay, constraint. So for the operator, so let's do the constraint first. So David cannot work more than 7 hours. Well, here's pretty much everything we need for this line. He cannot work, right? It cannot work more than 7 hours. So it's going to be less than or equal to 7 hours. So these are going to be the values that we're going to be looking at now when we run the solver. And this value right here, it can be less than or equal to 7, right? Same thing goes with Anita. It says Anita cannot work more than 12 hours per week. So we're going to go ahead and put 12. This is the same, right? Because she cannot work more than that time. So for the value, so we're going to use the formula sum product. So by using sum product, let me look at my notes. On sum products, we're going to go ahead and we're going to use the David's time, comma, how many to produce. We're going to hit enter. And here, we have to go ahead and command T for this array so it doesn't go away when we drag it down. Okay, because we're going to do David's time and Anita's time. Okay. So now we have to go ahead and run the program. We're going to go ahead and go to data, and then we're going to hit solver. Okay. So as you can see, this right here looks exactly like this right here that we have to replace once we have this one down. So let's focus on this one. So it says set the objective. Well, the objective is going to be what? The total revenue. Then we're going to maximize, right? We say here maximize revenue. So we're going to maximize the revenue by changing which cells. So I'm going to change this cells. How many to produce? That's going to be my changing variable. Now we have to add the constraints. So I'm going to hit add. Sorry, okay. So for the first constraint, so the constraints right here, right? It's pretty easy. It says constraints, and these are right here. Since these two have the same operator, we can put them together. So it can be this cells less than or equal to, if you just click here, you can change it, right? Less than or equal to which cells? These cells right here. I'm gonna hit enter and I'm gonna hit add. My second constraint, so that's the explicit constraint. The implicit constraint, it can be that, is that these two, so how many to produce, these values right here, it cannot be a negative number. So they have to be more than or equal to 0 because it doesn't make sense that we produce -1 mailbox or -2 toys. We either don't produce anything or produce something. So we're going to hit OK because that's going to be our last one. So these are our two constraints. And here, by selecting a solving method, we're going to go ahead and do simple LP. And we're going to hit solve. Okay. I guess we wait. All right. It says solver results, keep a solver solution. Then we're going to go ahead and hit OK. And these are the values that they found for us. They found that it's better for us to make 0 mailboxes and 7 toys to get a total profit of 154, and both of them can work 7 hours. So let's see if this is right. So we're going to go ahead and reference this. The mailboxes, how many mailboxes? 0, right? Toys, how many toys? We're going to reference back to the toy cell. And these are how many we can produce for a total revenue of this right here. And let's see if we did it correctly. This is question number 3. So we're going to go to answers. And then we're going to go to question number 3. And we see that we have 100%. And that's the end of the question.